In this chapter, we are going to look at pointers and arrays and how arrays and variables are represented in the memory in both C++ and MIPS. And we're going to translate some of C++ code that involved arrays and look how that is done. So if you look at here, we have the two variables, and the way that we can represent that in MIPS is that basically having some labels, and these labels gonna reserve some memory as soon as you put them in the data section. So for example, you're putting here x and word, that's the size of this variable that you want to define, and the number 4, which is the value. So as soon as you put this in your code, these two labels are going to be pointing to some memory location that's going to be reserved for your variable. So the reason we are doing it, because so in your C++ code, for example, you're going to have so many different variables, right? You could have a program that is you have like many inputs maybe, or so many variables that you're holding reference to different things. But as you saw in the previous chapter, we only have let's say 32 registers for basically like as a space to store these content that you have. So if you have more than that, then we are going to do this. We need to store these in the memory. So as we talked about before, this x and y are basically labels. It is same as that main and let's say exit that you had. They are all pointing someplace in the memory. So what happens when you load your program? There is two parts that we're going to look at. One is the main, one is, sorry, the text section, and one is the data section. So the data section, we said that's like kind of variables. You can put the strings, you can put numbers, you can put, like any like arrays and all sorts of data that you want to keep. The text was your code. So both of these are going to be stored into memory. So here you see that the main start at this address. So that's the beginning address for main, and that is we are talking about this MIPS processor that we are working with. For different processor, this doesn't hold true. It varies basically depending on the processor. So you see here that you have 00400024. So that's this address, and that's gonna be the first line of your code that you have. So let's say here, whatever you have here, that line of code gonna be stored here in this memory location. And then the next line of your code or next instruction gonna be located on the next address with offset of 4, because we said we are working with 32 bits in MIPS. So each space is actually 32 bits. So every time we are incrementing this by 4. So basically that is your beginning of your text section. And then here we have 1001 and zeros. So that's basically beginning of your data section. So if you look at these variables here, so we have 4 and -1, and each of them is, so x is a word and y is a word, so that's the size. So these gonna basically be placed here. So that 4 and -1 gonna be in these two locations. And if you have more variables, they're gonna just continue to grow in this direction. So let's look at this notation that we have here, dot, for example, data, or dot text, or dot word. So these are directives, and they are basically hinting the assembler to do specific things. So we've seen that word, we said, is a size. So it's 32 bits, right? And you saw that when we were looking at here that we are defining a variable. So we said that this word, it's saying that basically this variable is 32 bits. So that's a size. And don't confuse that with the type. So in higher level language, for example, we have integer, string, or double, and things like that. So those are types. But here we are just dealing with the size. So this word, it's up to you what you are storing that. I mean, it could be a number, but that number could represent like an ASCII value. So basically, it's just a size. So you have byte, you have different sizes that you can align, and you can do arrays also. But basically, there is a directive. The other types that we've seen so far is data and text. So we said data is basically the section that is defining your memory, and text is basically your code. And this is, of course, read only, because once you load your code, you don't want it to be changed. So here we have a reminder. It says that MIPS arithmetic instruction have registered operands only. So if you remember, when we had add or divide or many of these different arithmetic operations, all of them took 3 registers. So we had, for example, add S0, S1, S2. So these operations or these instructions are only working with registers. So what if you had to load something from the memory, or let's say you had this integer in your memory. So like here, so you have this 4 and -1, and they are stored in your memory. So these are not in registers, right? What if you wanted to add these two numbers together? We don't have any instruction that you can give them these labels, like for example, X and Y, and add them together. We cannot do that. So how we do that then? We have to first load these and save these, read these values, save them to some registers, do the operation. Let's say we add them, and then if you want to, you can store them back to your memory. So we have two types of instruction for that. We have load instructions that gonna take data from the memory and save it into a register. And on the other way, we have a store instruction that basically takes a value that you have in your register already and save it to a memory location